This is a talk on MySQL indexes. This is a subject that when I start talking about it in the hallway at conferences, I end up drawing too many people around me. So I turn this into a talk. I am Dave Stokes. You can reach me at Stoker on Twitter. I work for Percona. If you haven't heard of Percona, we are database experts. We specialize in open source databases. My background, about 24 3/4 years ago, I was working for the American Heart Association and I needed a templating engine. And this guy named Rasmus Lurdorf put out something called Personal Homepage. At the same time, MySQL was launched, and I've kind of been using that as my career platform for 2.5 decades now. I'm a technology evangelist for Percona, which means I talk about databases, I talk about Kubernetes, our operators, PMM, which is our free open source monitoring tool. And I'm also the author of MySQL and JSON, a practical programming guide. Second edition is available on Amazon as we speak. If you've seen me before at CakeFest, that's when I was working for MySQL, either as MySQL AB, Sun Microsystems, or Oracle. So what is an index? Well, without an index, you have to read the entire book. As you see the book on the picture here, if you have to read through all of that, it's going to take a long time if you're looking for one piece of information. Now, computers, as good as they are, still aren't great at a lot of things. So if you don't have an index or a way to cache the piece of information you're looking for, it gets messy. Also, the data may not be ordered. What I mean here is that imagine your nephew has taken your dictionary and torn it up into little word-sized bits, and you're looking for the definition of the word moose. You don't know if you're talking about the animal, the dessert, or the hair product. So you have to go through all the little pieces to find the answer you want, and you still may not be sure which one exactly is the one you want to end up with. So we're talking about NODB indexes. Why is that? Well, NODB is the storage engine that Oracle is really pushing for MySQL. The days of MyISAM are long over. So if you want to get performance, it's going to have to be NODB. So with an index, you get the ability to go directly to the piece of information you want faster. The great thing here is that, you go right to the item you want. Now, I have no idea what bear baiting Kramer made Archbishop has to do with the world, but if I'm interested in bear baiting, I know from the index of this book that I go to page 88. So it's a lot faster. I don't have to read everything. I go right to the part I want. Now, MySQL uses what they call as a clustered index. This is a lot different than Postgres and a lot of other relational databases. Basically, your data is stored in a tree shape. Imagine this is the trunk and these are the branches, and this is called the root, and these are called leaf nodes. Very easy way to handle data, very easy to expand. Now, it's also very easy to search for one record or a range of records. So if I want to find record 22, I take this path here you see in red. If I'm looking for a range of records, like here between 17 and 42, very easy to know what to grab off the disk or out of memory. Very, very handy. Now, for MySQL, the records are stored by the primary key. And if you do not designate one, it will pick one for you, which is not going to be optimal. It's going to be 32 bits, which is probably way too big for what you want. And it's not going to help you out. So please, please, please pick your own primary key. Now, this is an idea of a clustered index where we have a table where we have our key and the data. So the system will look up stuff by keys and then go read the data most of the time. We'll talk about exceptions in a little bit. Now, if you have other things you want to index on a record, those are going to be called secondary indexes. And the secondary index hopefully is going to depend on a unique primary key that's not nullable. We'll talk about nulls in a little bit. Secondary keys are non-primary keys that are used to access records in a table. not knowable. So if you're looking up your car, let's say by the license plate number, and you're storing everything by the VIN number, that would be an example of using the secondary to get to the primary. Now, keys are what make up an index. So you could say an index is a collection of keys. You don't want nulls in there. I'll explain that a little bit more later. By the way, secondary keys are stored next to the primary key logically, so that if you have very long primary keys and very long secondary keys, that's taking up a lot of space. And the smaller your key is, the better. By the way, UUIDs, GUIDs are not good ideas as primary keys. They don't monotonically increase, which means they don't increase by 1 or a set limit over time. The way the B tree works is it likes to be able to add on to the right side of the tree as it builds stuff, and it rebalances itself as it goes. UUIDs are all over the place. You end up with big empty holes in your pages, and not recommended. You could use them as secondary. Don't really recommend them. They're kind of too large. And by the way, there are functions that let you get away with that. So indexes are easy to create. But remember, every index takes up space, which is both on disk and in memory. And there's overhead for maintenance. So every insert, update, or delete, there's overhead required for that. And you can actually build it so many indexes that the system has a hard time getting out of its own way. So, quick demo. We're going to create a schema called PL demo. We're going to use that schema. By the way, in the MySQL world, we use schema and database interchangeably. Now, in this example, we have a table creatively called EX01, and it's using a column named MyID. We're going to define it as serial, primary key, C1, which is going to be an integer, and C2 is going to be an integer. You see serial a lot more in the Oracle and Postgres world. It has its own special meaning. You'll see what that is in just a minute. So if we do show create table EX01, it will come back and show you that MyID is defined as a big integer, which is, I think, is 3.2 quadrillion records. Unsigned. Don't use the signed version of integers for tables because you lose basically half the values that you can use. Not null, and auto increment. That means every time you add a record, it will automatically append a new record with that index number bumped. And it tells us that our primary key is this column here. It also tells us that the unique key is out there, because serial defines things as unique, and here we've specifically said it's going to be a primary key. So we end up having here two. This is a better look at that. So let's go through the definition. Big int unsigned. So you have a range of 2 to the 63rd. Not null. We'll talk about nulls a little bit. Nulls are kind of nasty for indexes. And we have 2 keys on the table. In MySQL, this is a no-no because these 2 keys are referencing the same column. You don't want that. If you had to do this again, we do this without the serial definition. We just do it as big int unsigned instead of serial. Now, with this, there's double the overhead for maintaining those indexes when you only need 1. So we can skip the unique key. By the way, in Postgres, you do this occasionally. The idea is that you can reindex one of the indexes while the other one's being used, and the system will switch over to the one that's more up to date on the fly without you having to worry about it. So, big recommendations where you're making primary keys, and please have primary keys on your tables. Use int, big int, unsigned, not null, auto increment. Well, what if we want to search for just the first 5 numbers of the customer ID, or there's a lot of redundant data in your columns? By the way, I just did a podcast earlier today with one of our engineers on finding bad schemas, where we talk about the tools and the queries that will let you find this. So let's insert 100 records into our table that we created earlier. And when we do a select star from EX01, where MyID equals 7, it comes back here and tells us the possible keys it's going to use. And of course, it picks the primary. By the way, key length is the number of bytes of data that's actually used to look up the number of rows that we want that's going to be returned. Now, we're going to use the bad case from the previous one to show what happens when you actually have two indexes out there. So for comparison, we're going to have another table that is created same way. The only difference is instead of serial, we have it as an integer unsigned, not null, the way I asked you to do that. We're inserting some records. So when we have no index at all, so ignore the previous indexes, and we do this, and we do that, it tells us it has to do a table scan on the table. And the cost of it is 10.25 units. Now, this is normally measured in disk reads, because disk reads are the most expensive things on a server. Reading stuff out of memory is 100,000 times faster than reading off disk. And it tells us that we're going to have to read 10 rows. Now, I can guarantee that the data here is all sequential. There's no duplicates. So it's guessing that it's going to have to go out to that table and grab a chunk of 10 records to be able to return the information we want. Now, if we do this with the index out there, it comes back, and notice the cost is jumped down to 0 from 10.25, and it's only going to have to read one row of data. Well, this is the miracle of indexes. It is able to find us what we want just from reading the index. It doesn't have to dive into the data. This is explained with format equals JSON, which comes back and gives us a little more detail on our query, the various costs for read evaluation, and all that. So we've proven that indexes do work. Why don't I just index everything? No, that's not a good idea. So what can I index? Well, just about anything you really want. There are some cautions I'll give you. By the way, you can also create indexes by using the alter table command. So we're going to pretend that we're all employees of a new company called Yonkbox LLC. Congratulations, and our first task is to create a schema for the order of Yonkboxes. Wonder what, I got a slide out over it. So covering indexes, what you saw earlier, was getting the answer from just the index. For those of you who don't know, this thing down here in the corner is a Yonkbox. My former boss at Percona created this to be able to demonstrate our PMM management tool. By flipping a switch, you get rid of an index, change a data type, just the amount of queries going into a box, the number of connections. And it's very handy to demo what's going on with a database and when you're showing off management software. So let's create a table, have an order ID, we have a customer ID, we have an order date, an estimated delivery date, an item number, and a worker. And we know each Yonkbox has a serial number, hopefully a customer, a date when it was ordered, an estimated delivery date, an item number, the type, deluxe unit, a platinum edition, and maybe a worker who's assigned to the product. So if we want to search quickly by customer ID, and this is why it helps to know how you're going to be searching for your data. Let's take a look how we can do that. Well, it's real easy. Create index, and I like to explicitly name my indexes to make sure that you have the table name there and the column name, and make it very easy to find. So we're going to index the customer ID. So I use that as the index. I put in the table name there. You can use your own convention. I found that when I'm hunting for an index, if something's too similar to something in another table, I end up grabbing that, which is not what you want. So be explicit. Well, what if you want to be able to give it a location? Well, MySQL has a geometry table or index type, which is actually based on an R tree, not a B plus tree. And to do that, we can alter the table, and we add a column named G of type geometry, and you have to specify the identifier that you're going to use for the geometry types. MySQL has over 5,000. And once you do that, you can add point data all day long. and then we can go back and add a spatial index. So if you need to be able to track the box down to a specific longitude and latitude, we've got that covered. Keywords. What if you want to be able to search the products that you're searching by a specific keyword? Well, we're going to add a column called description, and we're going to make it terribly large on varchar 500. And then we're going to make that a full text index. So we can go out and do text index searches against what we have in the description column. For example, we're going to go out there and look for the order number, customer number from our customer order table. And we're going to look for the word gold in the description anyplace. And it comes back with the 2 pieces of information we asked for. Functional indexes. These really are the fun part of functional indexes. They let you define an index to be manipulated by a value or some sort of computation. Now, let's say like we want to have an index where we want to know the estimated month of delivery. So we're going to use the month function on that date field just to return the month, and then we're going to index that. By the way, searching by dates in MySQL usually is very slow because it has to do a whole bunch of conversions. If you're going to do that sort of work, I definitely recommend materializing, which means take all this data and put it in its own column or its own index. So when we do this index and we're looking for that one record, it comes back and tells us that it's going to be a cost of 0.35. It's going to rerun row. If you run this without the index, you find that it has to do a full table scan, which means it has to read everything. It does not help. Now, another idea that you can do with a functional index is to do some sort of calculation. So like you have a standard markup, which is the cost of all the components in the box, plus an overhead to cover your rent, electricity, salaries, and whatever else goes on there. And here's an example where we're going to search for something where the cost of the goods sold times 1.5 is greater than 10. The optimizer knows how to pick up this information, and it tells us that it's going to be able to do a scan on all the products, which means an index scan, not scanning the actual table, to get our information. And it's going to come back with a cost of 1.16 units and 2 rows red. Now, notice that, never mind. Okay, multi-value indexes. When MySQL added the JSON data type, a lot of people realized that MySQL did not have an array data type, but they could use the JSON array as a array data type. Now, traditionally, MySQL and most of the databases have a 1 entry in an index to 1 entry in a table construct. Well, it doesn't work when you have arrays, so you need 1 entry in a column or an index running 2 multiples. So that's what multi-value indexes can do. So in this example, we have people with multiple zip codes. This could be multiple phone numbers, multiple order numbers, multiple tasks that they're doing. And this is a JSON document called info. So what we're going to do is we're going to go out there and we're going to check with the multi-value index that zip code matching 1, 2, 3, 4, 5 is in this group. And when we create our table, the way we do that is we specify we're going to have an index, and you have to take the zip code information, zip code data. This is the path in the JSON document. Anything starting with zip code in the info column is going to be cast as an unsigned array. And now we have a way to quickly go through all the data. So multiple column indexes. Let me run through this. Traditionally, the idea was that if you're going to index on something on year, month, day, that index should work on year, month, day, year, month, or year. It couldn't actually cross over to some of the other values. We'll show that that's not always the same. But the basic idea is you put the highest cardinality first. So year, you have fewer years, more months, and then even more days. and keep doing that until you're out of columns. And I think you run out of ability to do that at 16 different columns being indexed. So let's create a table. Here we creatively call it X. We have 3 columns, and into those columns we're inserting some data. And when we run explain on our query, and we're looking for a record where C1 is equal to 1, C2 is equal to 2, and C3 is equal to 3, which just happens to match this one here for those who, it's going to be able to look up all this information on using the index. Let's change this around just a little bit. Let's just look for C1 and C2. Well, it's still using the index lookup, so we're not actually having to dive in the data. Now, let's take a look where we're looking at C1 equals 1 and C3 equals 3. So we're basically skipping this C2 equals 2. So it still does an index lookup. So we can use this to pin and skip columns if we have to. Now, where this doesn't work is where we're searching on the second and third columns and leaving the first column alone. The optimizer doesn't know how to use the index for that, so it has to do a table scan. So be careful on how you search for your data. Now, the other thing is covering indexes. I mentioned this before. This basically means that it's getting all the data off the index, not actually diving in the data, which is a lot faster. Foreign keys. This is something that in the MySQL world you either swear by or swear at, and there's more swearing at than swearing by. The idea is you populate a parent column with a value that is referenced from the child column, and there are all sorts of neat tricks you can do with it. I'm not going to go into the politics between the implementation. I know it's good. Example here, creating a table called parent, and it has an ID column that's an integer, and it's our primary key. When we create the child table, we tell it that there's going to be a column called parent ID, and that it's going to reference the parent table ID column. And we also index that for making faster searches. Whoops, let me go back. Now, the great thing about this delete Cascade, that if I get rid of the parent, it also deletes the child table for you. Some people do not trust that. It's probably good maintenance not to trust that. But if it works for you, it's going to be great. Hash joins. This was something that was added about a year and a half, 2 years ago in MySQL, something long asked for. It's more efficient than traditional nested loop joins that MySQL does. What MySQL traditionally does is it takes the smaller of 2 tables being joined and jumps over to the second table looking for the information. Hash joins, it basically takes the values, hashes them together, and where there's collisions, where there's multiples, it returns that information. This is really, really fast, especially if it's in memory. Now, if you've never seen one of these before, it needs equalities. It has to join on equalities. If it's not an equality, it's not going to use the hash join. So if you're in a case where you're matching things exactly, it's great. And when you run explain, it's going to tell you the type of hash join that it's using. Now, from using this, you can see that we have an inner hash join, another inner hash join, and then it actually goes out and does a quick little, does a table scan on B to get the values to be hashed, and then does another quick little scan on A, and then does the hash join, which is still faster than the nested loop join. Invisible indexes. MySQL 8 started this support for invisible indexes. When you make an index invisible, the optimizer cannot see the index. It's like it's hiding someplace and it can't be seen. Now, this also can be used with indexes that aren't primary keys. I don't really recommend using it on primary keys. There's some logical issues there. By the way, the reason you use a lot invisible index is you have an index that you're not sure is valuable, you don't think it's helping people, and you turn it invisible. It can't be seen. Previously, what you would do is you delete that index, and then 15 minutes later, your phone starts ringing off the hook. People are complaining their queries are going slowly, and you suddenly realize that you really need that index back, and it may not be a quick rebuild. So let's do a quick little example here. Let's go out there and we're going to select the count of the country code from the city table. This is part of the world database that MySQL has used for years and years, where the district equals Texas, and it comes back that it has to do a full table scan, has to read everything in the city table. The cost is $442. It has to read 4,100 rows, almost 4,200. Now, if we add an index onto the district column and we rerun our query, notice that it's now doing an index look up on that table, and its cost has dropped from 442 down to 9, and it only has to read 26 rows. Now, if we make that index we just created here invisible, we go back to the old ways where it can't use that index and it has to do a full table scan. Histograms. These are an interesting option that also came in with MySQL 8.0. It's an option instead of using an index, and it works really great if you have data that has a low churn rate. If you have something out there that's fairly stable, consider using a histogram. Now, the trouble without a histogram is that the optimizer by default figures if you have a column and there's some sort of value in there from top to bottom, it's going to figure an even distribution. And that's very rarely true in real life. If you have something like a Poisson distribution, you're going to find out that histograms are pretty neat. So, great example here. Let's create a table called H1, and it's going to have a column named X that's going to be unsigned data, and into that table we're going to insert 1 1 2 2s, 3 3s, 4 4s, and one value of 17. So the one thing to notice here is that all the values of X we're inserting are greater than 0. So when we do a select star from this table where X is greater than 0, we know all the values in there right now are greater than 0. Optimizer doesn't know that. It knows there's 11 rows in there, and it figures I'm going to have to read a third of those 11 rows to get the information I want. This is like the contractor who says, oh yeah, I can re-roof your house in 2 days, and 3 weeks later they're still pounding away on above you. So let's, once again, this estimate is going to have to read a third of the 11 rows out there to find all the records where X is greater than 0, and we know X is greater than 0. So we're going to use the analyze table command, and we use the keyword update. It's either update or delete. There's no create, it's just use update. We're going to tell it to create a histogram on our table with 10 buckets. You can have a multiple of 1,024 buckets. There's two types. One, there's the singleton, where you have one value per bucket. So you can have a range or all that. The other thing is actually more of a range type, where so like you're going to have 10 buckets. We're going to divide the data up by whatever the number is over 10 and put those in the buckets, so you can end up having a range. Kind of like where you have the alphabet split A to L and then M to Z. So we put in our histogram and we rerun our query. Oops, and this is falling off the table. I'm sorry. It actually comes down here and says that we have to read all 11 tables, and that's 100%. Not sure why that's falling off. So when do you use an index? When do you use a histogram? Well, indexes are fast. They require maintenance and overhead. Every so often, the server will dive in and read a certain percentage of the index headers to make sure that things are right, to update the statistics. They take up space on disk and in memory. Now, histograms are fast, not as fast as indexes most of the time. Requires maintenance as the data ages, which is actually fairly quick, so you can put that on a cron command. But it's not for rapidly changing data. So if you're doing transactions with a histogram table, not going to be happy. And woo, that was a lot to cover. And I want to thank you for listening. By the way, this is a presentation I gave at Scale 19X. If you have questions, reach me at Stoker or david@stokes@percona.com. And the slides are out there at slideshow.net/David M. Stokes, or ping me at Stoker.